So the last comic we'll deal with is the hyperbola, right? And the first thing we're going to talk about is graphing these hyperbolas. But let's talk about what a hyperbola is. Hyperbola now is a set of all points in a plane such that the difference, right? Remember, an ellipse was the sum. A hyperbola is the difference of the distances from two fixed points is constant. Meaning, if I take a point on a graph, right, the distance from that point to F1 and that point to F2, right? Right there, the difference of that, those distances will be constant, okay? And that's important to know. And also to know the difference between hyperbola is difference and ellipse is sum. So let's take a look at the equations of it. Now, if you look here, hyperbolas can open up left and right, but they can also open up and down. If you look at the equation here, if x is first over a squared, so if it's x minus h all squared over a squared minus y minus k all squared over b squared, right, it's going to open left and right. If the y is first, if you look here, right, if you look right there, you'll see now they switched it where y is y minus k all squared minus x minus h. If the y comes first, it's going to open up and down. Okay? That's important to know and recognize. Now, a is not the biggest number here all the time. Okay? You have to pay attention to a squared is always under the first fraction, but we have to pay attention, is x first or is y first? Now, so these hyperbolas, right, have two types of axes, right? One axis that we're going to pay attention to a little more than the other is the transverse axis. And that's the axis that goes through not only the vertex of the hyperbola, all right, but also the foci of the hyperbola, right? Now, there is another axis, and that is if I draw another line through the center, this is called the conjugate axis, right? So now, when we look at it, if your transverse axis is parallel to the x-axis, this is what we would use for the foci, right? This is what we would use for the vertices, and this is what our equation would look like. Now notice here, when we look at it, another difference here, and I kind of don't like in this chart how this is written, but one thing I'm going to tell you, the distance from the center to the foci now, c squared, is equal to a squared plus b squared now. So if you remember in the last one, in an ellipse, it was a squared minus b squared. Okay, so now, let's take a look at this. So the first example, and I apologize, there are no graphs in here, so you're going to have to draw them on your own. So, first thing I'm going to do is draw my coordinate plane, and I'm going to identify the center. The center is no different than all the other ones. The opposite of -1 is 1. The opposite of 2 is -2. So we have 1, -2 is our center. Now, the vertices, right? What we need to know is what A is for the vertex. So right now, the vertex is going to be at, if A squared is 4, A is 2, B squared is 16, so B is 4. I'm going to explain that in a minute. Now, since we look at x's here first, right, we know our hyperbola is going to be like this. Okay, we know it's going to open left and right. So what I'm going to do is plot the vertices. So from the center, what I'm going to do is if a squared is 4 and a is 2, I'm going to go 2 to the left, plot a dot, that's one vertex. 2 to the right, plot a dot, and that's my other vertex. So a hyperbola will have two vertices. So in this case, one vertex is at -1, -2. The other vertex is going to be at 3, -2. Now, what we have to do now is we're going to use b. Now, if b squared is 16, we know b is 4. Now, what I'm going to do is I'm going to kind of draw an imaginary line through each vertex here. Now, when I do that, and I know this sounds crazy, when I do that, what I'm trying to do is create a rectangle. Now, when I create this rectangle, what I want you to pay attention to is if b is 4, from the vertex, I'm going to go up 1, 2, 3, 4. I'm going to go down 4, 1, 2, 3, 4. Then, again, I'm going to go up 4 from the other vertex. I'm going to go down 4 from the other vertex, and I'm going to create a rectangle. Now, the reason we use this rectangle is because it's going to give us what we call our asymptotes. What I'm going to do is connect and draw a line through the diagonals of this rectangle. Now you should notice the center should go through that intersection point, but it's hard to draw on this. But what I want you guys to notice now is these asymptotes. If you remember what an asymptote is, it's they are lines that the graph gets close to, but never touch. So when I look at these asymptotes, they're really going to help me, identify the shape of the hyperbola. So what I do now is from this vertex, I know this graph is going to be shaped just like this. It's going to follow and get close to those asymptotes, but never touch. Same thing over here. Close to the asymptotes, but never touch. Right, like that. All right, now, what we need to do here, right, is identify a couple of additional things. One, the foci. Remember, c squared is equal to a squared plus b squared. So, if c squared is equal to 4 plus 16, c squared is equal to 20. So c is the square root of 20, which is approximately, it's 2 root 5. Now, from here, we know that c is the distance from the center to the foci. So if my center is right here, what I'm going to do is I'm going to add 2 root 5 to the center to find this one. Then I'm going to subtract 2 root 5 from the center to find this foci. So right now, when I look at the foci there, my y value actually stays the same. But if my center was at 1, -2, I know right away this is going to be 1 plus 2 root 5, comma, -2. The other one would be at 1 minus 2 root 5, comma, -2. Okay, so remember, to find those, that's what we're going to do. Now the asymptotes. What we have to do here is basically write the equation of both lines. Now, to write the equation of the line, first thing I need is the slope. So what is the slope of each of these lines going to be? Well, if I go from the center, right, how many do I have to go up? I have to go up 1, 2, 3, 4. So I go up 4, and I'm going to go over 2. So the slope of this line is 2. So now I'm going to use that point and the center to write my equation. And if you remember how to write the equation of a line, my slope is 2. So slope of 2, and my center goes through 1, -2. I'm going to say y equals my slope times x minus 1, all minus 2. And then basically, I'm going to go ahead and distribute and then combine like terms. So one asymptote is y equals 2x minus 4. Now my second one, the only difference here is instead of my slope being positive, now my slope is negative. So this line has a slope of -2. So I'm going to use that in my center. Slope of -2, 1, -2. So y equals -2 times x minus 1, all minus 2. When I distribute, I get y equals -2x plus 2 minus 2, which gives me -2x, because those add up to 0. So my other asymptote is y equals -2x. And those are literally just writing the linear equations. Okay? So the next equation, if you remember, up here, on the other page, right? When you look at this, all of these equations are equal to 1. So right now, just looking at this, is that equation equal to 1? All right, no, it's not. So what am I going to do? What I'm going to do is I'm going to divide this side by 108 to make sure that equals 1, which means I'm going to divide everything by 108. Now, when I do this, okay, I'm going to end up with x squared over 6 over 108 reduces to 1 over 18. So it's x squared over 18 minus y squared over 9 equals 1. Now, if it's just x squared and y squared, I know my center is at 0, 0. Now the vertices, this will be a little more difficult, right? So when I look here, my center is at 0, 0. So the square root of 18, if we go ahead and do that in the calculator, right, we get the square root of 18 is about 4.24. Why do I need to know that? Because if a squared is equal to 18, a is equal to the square root of 18, which if we simplify the radical would be root 9 times root 2, which is 3 root 2. But as a decimal, it's about 4.24. Now we know b squared is 9, so b is 3. So the first thing we're going to do is we're going to move the vertices, or find the vertices. So from the center, I'm going to go right 4.24, which is right about there. And I'm going to go left 4.24, which is right about there. Okay, so now those are my vertices. And if I look, they're going to basically be 3 root 2, comma 0, and then negative 3 root 2, comma 0. So let's use b now. So if b is equal to 3, from my vertex, I'm going to go up 1, 2, 3, down 3, 1, 2, 3, and I'm going to duplicate it on the other side. And then basically, here's that rectangle. I'm going to go ahead, construct my asymptotes. They should go through the center, right? And now I can sketch the shape of the graph. So right away, comes like this, and it follows those asymptotes. Right here, it's going to come out here, follow the asymptote. All right, so now the foci, remember, is c squared equals a squared plus b squared. So c squared is equal to 18 plus 9, which is going to give me the square root of 27. Now that would simplify to 3 root 3. So remember, the foci are going to be on the same transverse axis as your vertices. So if my center is at 0, 0, I'm going to add 3 root 3, and I'm going to come over here and I'm going to subtract 3 root 3. So my foci are going to be at 3 root 3, comma 0. Okay, so this is at 3 root 3, comma 0. This one's at negative 3 root 3, comma 0. All right, now the equation of my asymptotes, right away. If I look at my slope, right, my slope is going to be up 3, right, up 3 over root 18. So my slope is 3 over root 18. So if you remember from math 2, we used to rationalize this, where it would multiply numerator and denominator by root 18, and I would get 3 root 18 all over 18. So that's going to give me 3 times. This simplifies to 3 root 2 all over 18, which gives me 9 root 2 over 18, which equals root 2 over 2. Now, the reason that is because 9 over 18 simplifies to 2. Now, with this, my center is at 0, 0, so writing this equation is real easy. So y equals my slope, root 2 over 2, times x minus 0 plus 0. It just ends up being root 2 over 2x. So that is one asymptote. The other one, you know, your slope is just, if this one's positive root 2 over 2, your other slope is negative root 2 over 2 times x, and you are done. All right, now that asymptote is a little more difficult than all the other ones, but we need to be able to kind of just have an idea. They won't be that difficult on any exam. All right, couple more left. Let's take a look at this. For this one, right away, we're going to again group the terms. So we have y squared minus 2y minus 4x squared plus 16x equals, I'm going to add that 19 to both sides, and it equals 19. Now notice, I put y first because you see how it's y squared minus 4x squared? I know right away that that is very important to know, because in a hyperbola it's subtraction. So what are we subtracting? We're subtracting the x squared term in this problem. So now I'm going to go ahead and complete this square here. Y minus 2y, half of 2 all squared is 1. Now I'm going to factor out that minus 4. And when I do that, it's going to give me, if I divide by negative 4, divide by negative 4, it's going to give me x squared minus 4x. But now I have to complete the square in there, so I add 4 equals 19. This here will factor out to give you y minus 1 all squared, minus 4 times x minus 2 all squared equals. Remember over here, I added 1 here, so I'm going to go ahead and add 1 here. Now, this is the tough part. What did I really do to this side? To this side, I really subtracted 16. So I'm actually going to come over here and subtract 16. I know that's confusing, but remember, what you do to one side, you do to the other side. So 19 plus 1 is 20, minus 16 is 4. So what I'm going to do now is divide everything by 4 to make this equal 1. So I get y minus 1 all squared over 4 minus, these 4's cancel out, So I'm going to say it's x minus 2 all squared over 1 equals 1. Right away. So now when I go to find my center, right, what you guys have to understand is the x-coordinate of my center now is over here. So it's going to be at 2 and then 1. So my center is at 2, 1. So now when I look at my a squared is 4, so a is 2. B squared is 1, so b is 1. So now to find my vertices, remember, if this is y minus something all squared minus x squared, you know it's opening up and down. So in this case, when I go to my vertices, if a is 2, from here I'm going to go up 2. Then from the center I'm going to go down 2. So one vertex ends up being at 2, 3. My other vertex ends up being at 2, -1. So now if I use the b in this case, if b is 1, I'm going to scoot over 1, to the left 1, I'm going to go right 1 here, left 1 here, and I'm going to build that rectangle again. And when I build that rectangle, now I can draw these asymptotes in. But remember, we said a minute ago, since y is written first, we know it's going to open up like this and down like this. Okay? Now, our foci in this case, right? Our foci, what we're going to do is find the value of c. So if c squared is equal to b squared, or a squared plus b squared, c squared is equal to 5, so c is root 5. Now what you have to understand is my foci is going to land somewhere over in here. Okay, it's going to land like, say, there and there. But how do we find those values? Well, we know both of these are going to have the same x value. So that's going to be 2 comma something, and this one's going to be 2 comma something. Well, remember, c is the distance from the center to the foci. So what are we going to do to a y value of 1 to get to that foci? Well, we're going to add, so it's going to be 1 plus root 5, and the other one would be 1 minus root 5. And that would give us our foci. Now, for our asymptotes, the slope. When I look at the slope here, right, the slope is 1, 2 over 1, so that slope is 2. This slope is -2. So if my center is at 2, 1, I know y equals 2 times x minus 2 plus 1. That's going to give me 2x minus 2 plus 1, which is going to give me 2x minus 1. That will be one of my asymptotes. Excuse me there. Let me rephrase that. This, when I distribute that 2, this is going to be 2x minus 4, which makes this 2x minus 3. All right, because -4 plus 1 is -3. Now, the other one is going to be -2 times x minus 2, because the slope is -2 now, all plus 1. So y equals -2x plus 4 plus 1. So y equals -2x plus 5. That would be your other asymptote. Okay? And again, that's just writing the linear equation. All right? Now, this last example, do me a favor, go ahead and try it on your own and come back and check your answer. So right away, if we look, 25x squared We're going to do plus 100x minus 4y squared plus 24y equals 36. I get that when I add the 36. So I'm going to factor the GCF out here. So 25 times x squared plus 4x, but I'm going to complete the square at the same time. Minus 4 times y squared. That's going to be minus 6y plus 9 equals 36. But if you look, 25 times 4 is 100. So on this side, I have to add 100. Here, negative 4 times 9 is negative 36. So I have to come over here and subtract 36. So what this gives me is 25 times x plus 2 all squared minus y minus, 4, oops, let me rewrite this, all squared minus 4 times y minus 3 all squared equals 100. Now, I'm going to divide everything by 100. This gives me 1, 4. This gives me 1, that's 25. And that's going to be 1. So our equation is going to be x plus 2 all squared over 4 minus y minus 3 all squared over 25 equals 1. Since x is written first here, we know right away this is going to open up left and right like such. So let's go and find the center here. Our center is going to be at negative 2, 3. So negative 2, 3. And now to find the vertex, let's find a. So if a squared is 4, it means a is 2. If b squared is 25, that means b is 5. So right away from my for my vertices, I know because it opens left and right, I'm going to go to the right 2, 1, 2. And I'm going to go to the left 2, 1, 2. And now I'm going to use that b to build my rectangle. So from my vertex, I'm going to go up 5. So up 1, 2, 3, 4, 5. Up 5. And I'm going to go down 5. 1, 2, 3, 4, 5. Down 5. And now I'm going to build this rectangle. I'm going to draw in my asymptotes. Ooh, sorry, that's kind of bad. And now I can sketch my parabola. Or sorry, hyperbola. So my vertices in this case ended up being at, what is that going to be, 0, 3? And my other one is at, if I'm not mistaken, what is that, negative 4, 3? Now my foci, c squared is equal to 4 plus 25. So c is the square root of 29. Since it's opening up here, our y value is going to stay the same. So what we're going to do is add to the center here, to the x coordinate, we're going to add root 29. So what is that? Negative 2 plus the square root of 29, comma 3. That's one foci. And the other one's going to be negative 2 minus the square root of 29, comma 3. And just let you know, your asymptotes real quick would be y equals 5 halves x plus 8. That's one of them. And the other one is 5 halves x. Negative 5 halves x minus 2. All right. So go ahead and attempt the homework, and I apologize for the long video.